Hi Pre-Cal, and today we're going to be considering a geometric sequence. And we know this is a geometric sequence because it does not have a common difference, it has a common ratio, a common rate of change as we go through. Obviously, we're doubling every time. So we're going to be writing the general formula or the general rule for this particular expanded sequence. So first of all, what do we know? We know that the first term is 1/2, and obviously here the common ratio is going to be 2 because it's doubling every time. So a sub 1 is 1/2 and r is 2. That's pretty easy to see. Now this one, super simple, but let's apply what we're going to see here when we look for a pattern in this expansion. That might help you in ones that are subsequently harder. Just as another reminder here, in terms of n, the domain for n is only going to be positive integers. Recall why. The reason being, n represents the physical location in the list. This is the first term. This is the second term, the third, the fourth, the fifth, the sixth, and so on. So a sub 1, a sub 2, a sub 3. Just a reminder that the domain here for n is only positive integers. So if we start writing these out, this is a sub 1, which is 1/2, and then a sub 2 is 1/2 times 2. A sub 3 is 1/2 times 2 times 2, or half of 4. A sub 4 is 1/2 times 2 times 2 times 2, or 1/2 of 8. And of course, we can write this using an exponent here. A sub 5 is 1/2 times 2 to the 4th. And of course, since 4 is 1 less than 5, our general rule here is simply going to be a sub n equals, not 1/2 because we're writing it in general terms here, but since 1/2 is a sub 1, a sub 1 times r, which is 2 to the n minus 1 power. So this is our general rule or general formula for this geometric sequence.